Hi everyone, the next topic is T random variable and T distribution. So this distribution or random variable is motivated by quantity, some estimate of beta divided by standard error of beta, beta hat. So this is sometimes called signal to noise ratio in engineering. So beta hat, so idea is we want to see if beta is really different from 0 or not. And the beta hat itself is the most important information to see if beta is 0 or not. But also, the second most important information is standard error of beta hat. So even if beta hat is large, such as 10, if standard error of beta hat is 20, then we are not really sure if beta hat is really different from 0. So T distribution, a T random variable is prepared to be used for this purpose. So the definition of T random variable. The T random variable with degrees of freedom n, or n degrees of freedom, is generated by this random variable. So here, z, x1, x2, up to xn are all independent standard normal random variable. So that is normal 0, 1. So often the beta hat is normally distributed, and the standard error is square root of variance, and variance is sum of squared quantities. So often this shape, the chi-square random variable, is useful to represent variance. So T distribution, T random variable are defined based on this idea. And here, the x1 square to xn square, the sum of these n terms is exactly the chi-square random variable. So we can say that T distribution is normal 0, 1 divided by square root of chi-square n divided by n. And here, if n goes to infinity, actually this goes to Tn goes to normal 0, 1, because we have the z over x1 square up to xn square divided by n, then square root. But you can see that if n goes to infinity by law of large numbers, so this approaches to expectation of xi square. And here expectation of xi square is actually the variance of xi, because xi has mean 0. And this is actually 1. So by this, we have n terms and divided by n, so this goes to 1. So this goes to just z, so normal 0, 1. So T distribution with a large degrees of freedom is almost the same as standard normal distribution. So graph is here. So T distribution with df1. So this has very heavy-tailed distribution. We have larger density when x goes to infinity and x goes to negative infinity. Of course, it converges to 0, but compared to T distribution or normal distribution with larger degrees of freedom, the tail is much heavier. So you can imagine that, for example, T distribution with df1 is z divided by x1 square divided by 1 take square root. So actually this is z over x1. So ratio of two independent normal standard random variables. And you can see that if denominator is around 0, that is actually often the case because this is normal 0, 1. If denominator is, for example, 0.01, z over x1 is very large number. If z is just 1 or 2, those are typical numbers, but still the ratio is 100 or 200. So we can imagine that the df1, the degrees of freedom 1, the T distribution is very heavy-tailed. And as these degrees of freedom gets larger, 1 to 5, infinity, actually this goes to normal. So actually this black curve, the t distribution with df infinity, this is exactly normal, 0, 1. So t distribution is also used to model the some heavy-tailed distribution. For example, the stock market return, daily stock market return, think about it. Then daily stock market return is sum of very small random variables. I mean, the daily return is maybe sum of 7 hourly return in US market, or 420 the minutely returns. So it's sum of many independent random variables. So it goes to normal, but in fact, still it's heavy-tailed. Sometimes market crashes, and sometimes we have very large gain in stock market in one day. So the distribution is probably similar to t distribution with df4 or df5 in my observation. So t distribution can be used for that purpose also. Yeah, so we have some exercise, so we will do this in quiz for homework. So now we have studied the t distribution and the t random variables. So original idea is t distribution will be used to test if some parameter is equal to 0. So t distribution is often the distribution of beta hat divided by standard error of beta hat. And the second use of t distribution is to fit some heavy-tailed distribution, such as the stock market return. So it's almost normal, but still we have some extreme events. So for that kind of distribution, the t distribution is useful for modeling.